Welcome everyone. Welcome to Women in Code Python Beginner Python Study Group. The session 8, the last session, which is the mini coding project. So we always have our awesome team members here. I'm Karen. I'm the volunteer of Women in Code Python, and I will be the co-presenter today.
Hi everyone, I'm Rishika. I'll be presenting alongside Karen today, and I'm a lead for the Python track.
Hi, I'm Stephanie. I'm an evangelist with Women Who Code Python, and I co-organize this awesome study group. Thank you all so much for joining.
Oops. So before we begin, just in case you just joined in, we will be doing our code on the local computer, your own local computer environment. Surprise! So if you have the thing, it would be great if you don't have Python on your computer. We strongly recommend you to download Python like right now, while we do the Women Who Code introduction. Also have a code editor ready, so you can choose the default. So when you download Python, it comes with IDLE, so you can use it as a code editor. We also so I will be using Visual Studio Code, one of the editor, and then Rishika will be using Sublime. So you guys can, if you guys want something, cooler, or you want like a different, alternatives to download Python, to edit your programming, any programming languages, like feel free to download these ones. So right now I'm going to show you guys how to open a terminal from the Windows side, and then Rishika will be showing how to open the terminal from the Mac side. So let's do this. So the fastest you can do it is to go to Start and type command prompt for all the Windows user here. So start command prompt, start and then type command prompt. Click it, and you will have a black screen there. For those of you who were on the second section, this is the exact same procedure to do it. So to check whether you have Python installed and ready, the fastest way to do it is to type Python 3 and then enter. So if you see Python 3.6 and then see this, there's just 3 arrows, that means your Python is installed properly and you're ready for this section. If you're not, let us know. We will try to help you to troubleshoot. And I will pass the screen to Rishika to show the exact same thing on the Mac side.
All right, so on the Mac side, there's a couple ways to get to it. There's kind of a search function that you can just do here, and then you can type in terminal and it opens up. Or if you go to your Finder and then go to Applications, then you're gonna have to scroll down a bit to Utilities. It's kind of tucked away in its own folder, and then open Terminal from here. Double click, and this is how it shows up. And so we'll be getting into exactly how to get to the proper folder to open all the different files and how to actually run the Python file from your terminal a little bit later on. But the way you can verify if you have Python installed is you can either type in Python or Python 3 and click enter, and then you'll see that now you've entered in a sort of a Python script where you can actually type out Python code now. So that's a really quick and easy way to figure out if you have Python installed. If you have any version of Python that's not Python 3, you can just type in Python. But if you have Python 3, then you type in Python 3, and that's kind of the preferred version that we would like to use. So that's everything for the Windows. Feel free to drop any questions in the chat if you have any questions about opening up the terminal, either in a Windows or a Mac. If not, then we will be revisiting the terminal when we get to to the live coding portion. But for right now, I think we can probably get back to the rest of the presentation.
Okay, that's good. Okay, let me share my screen. Okay, so let's see this. Okay, so I guess as usual, we were doing some Women in Code introduction first. So Women in Code's mission is to inspire women to excel in technology careers. Our vision is to have a world where women are represented as technical executives, founders, venture capitals, board members, and software engineers. Our target is for engineers who work for 2 or more years of experience, looking for support and resources to strengthen their influence and level up in their careers. We do take our code of conduct very seriously in order for everyone to enjoy and learn in a very safe and supportive environment. So if you want to check it out, feel free to click the link to check out the code of conduct. We have over 230,000 members across the globe. We have over 17 members in 20 countries. We have members in 90s, almost 100 countries. We have host over 10,000 events. We offer 2 minimum scholarship and 1,025 daily conference tickets. We also provide job access and resources and infinite support. We just see our future of movement as the world changes. We can be a connecting force that creates a sense of belongings while the world is being asked to isolate. So we have an exciting coming up event. I think the 3 of us will be there next week. Yes, the 3 of us will be there for the final session of the NLP, and then we will be doing something fun and coding, and I'll be helping her as well. So if you do register, or if you don't register, remember to register. And you want to keep everything, you want to keep update, you want to get our latest update information, as well as always follow us on social media, and we're on Instagram, Twitter, and LinkedIn, and also Slack too. So we will be doing the Pong game today. So we will be sharing something, and then we will be doing the Pong game, and then we will be doing the live coding. Rishika, would you want to take the introduction, or would you want me to keep going?
Yeah, I can take it from here.
Okay. I will pass it. Yeah.
All right. Yeah, so as Karen mentioned, I'm just going to give a brief introduction to Pong and the Pong game that we'll be implementing in Python. Today we'll be doing the live coding as we typically have done in previous sessions, but it won't be in Colab. We're going to be using a code editor and your terminal on your local environment. So things will be slightly different, but we hope that you can all still follow along and learn something new today. And then we'll just do a quick wrap up at the end. So Pong, as I'm sure maybe some of you have heard, it's kind of this simple game where you have sort of a player A and a player B, and then you kind of have these 2 paddles on both sides, and you can use a paddle to basically deflect the ball to the other side. And so the main purpose is to make sure that the ball doesn't, go through the border. So, right now, this is the case where the opposing players are doing really well, and they're able to successfully deflect it. But essentially, if the ball sort of just passes through and the paddle isn't there, then the other player gets a point. And so we're going to be doing a pretty similar implementation of this. So by the end of today's session, you'll be able to build a game that looks just like this. So this is 2-dimensional game that is basically simulating table tennis or ping pong. And as I mentioned, you have 2 players that are using these paddles, which are essentially these 2 white blocks. And then we also have this ball that's bouncing back and forth. Here are 2 links. This is a YouTube video to the tutorial that we're sort of referencing, where they walk through the code, and then the original code as well. So from here, we're gonna get into the live coding. So this is a link to a Google Drive folder that has all of these files in there. You're going to need to download the entire folder. So I recommend that once you access this to download the entire folder, it'll probably download as a zipped folder. So make sure to unzip it and open up all of these files. And they should all be contained within the same folder. And I'll show you why that's important, because you kind of need all of them to run it successfully. So what I'm going to do from here is, let me first make sure if everyone is able to access this folder properly. So this is not the same zip folder as on GitHub. It is a different one. This is basically just a Google Drive folder that we have given public access to, where you can find these files inside there. So if you click on this, it'll take you to this file, this folder. And you'll see all of these files here. So what you're gonna need to download is the bounce.wave, which is an audio file, main solution, main Pong new, and then Pong. So this Pong.py is the original source code. And what we have done is taken the source code and sort of restructured it, reformatted it to make it easier to present and explain for today's session. So we won't be actually code, for you to still download it later on. But what you're going to need are these 4 here. So please download everything in this. I'll give everyone a moment to do that. In the meantime, hopefully everyone has been able to get to download and install the code editor, or if they already have one installed, to have it up and running. And so that's going to be our next step, is that we're going to open the Pong new.py, that file. We're going to be opening that up in your code editor. So maybe I'll just give a minute to everyone to do that. Please let us know if you're having any issues. Since we are doing things a little bit differently, we can definitely help out. All right, so I'm seeing a couple thumbs up. So I'm gonna go ahead and get started. All right, so I actually already have the Pong new.py folder or file open, but say you had downloaded the folder to your desktop. So, this can be to anything. Typically it'll go into your downloads. I just have it on my desktop because it's sort of easier for me to remember, and there's fewer files to go through. And basically you can open this right here. So double click on that. And then on the Pong new.py, if you do a right click, and then you can say open with, and you can see all of these different options. I'm using Sublime Text. So you can just say open with Sublime Text, and that'll take you directly to what you see in the screen right here. If you're using Visual Studio Code, you can use that as an option. If you're using the IDLE, the Python 3 IDLE that comes whenever you install Python 3, feel free to do that as well. But I will be using Sublime Text. So I'm going to carry on with the code. So to sort of give you a sense of kind of why we have all of these multiple files, so let me pull this back in. So Pong_new is essentially where we have all of our different modules imported. We have a series of functions that are being defined for the 2 paddles that I was talking about. So 1 paddle for each player, to define the ball, so that the movement of the ball and how does that interact with the paddles. And then also to keep score, because it is a game, so we want to make sure that we are keeping score for player A and player B. So what I'm going to be doing is sort of walking through this entire file here. We're not going to be running anything. I'm just going to walk through this file here and show you kind of how we've defined all of these functions. And then I'm going to pass it over to Karen, who will sort of walk through the portion of actually doing some live coding. So we have some code already filled in for you, but there are some parts that we would like to fill out together. And so Karen will walk you through that section. So for right now, let me get started with the Pong_new.py file. So hopefully everyone has that opened up. So step 0 is importing the library. So, this is sort of a consistent thing we've been seeing, that a lot of times there are some libraries and some modules that we want to import so that we can actually use the different functions that they offer. So what we're going to be importing is Turtle, OS, and Platform. So Turtle is this module that's used for sort of these basic graphics. If you're building out a simple game like Pong, you want to use Turtle. It's a really nice and easy built-in module that works very well with Python. I used it in sort of one of my first introductory Python classes, and it kind of sets up that window that you see when you're loading the game, and you'll see that a little bit later on when we actually run these files. And then we're going to be importing OS. So the OS module is allows us to directly interact with the operating system. So whether that's Mac or Windows, through different text commands. And where we're going to be using this module is actually to run the audio file that you saw. So that bounce.wav file is actually just an audio file that plays like a bounce sound. And the reason we're using that is so that when you see the ball sort of hit the border and then it bounces away, when that happens, we want that bounce sound to be played. So that's why we're using the OS library. So next we're going to, next we have step 1, which is the paddles. So what we're going to be doing here is creating 2 paddles. So we have defined them as paddle A and paddle B, basically for player A and player B. And we're going to place them in opposite so as you saw in the slide with, both the paddles on each side, you want them basically mirrored against each other on opposite sides of the screen. So what we're going to do here is create paddle A and then define different features of paddle A, such as the speed, the color, and the position. So first, anytime that we want to create a new object, we have to do that using this turtle.turtle. So it kind of sounds repetitive, but essentially what you're doing is that we are defining this paddle_A as a new turtle object. And so the turtle here with the capital T is the name of the class. And then this underscore turtle with the T is actually the name of the module, just so you can, just for some clarity on that. Next, we define the speed. And so when we say .speed and then this 0 is what we're setting the speed to, this is actually the maximum possible speed. So basically setting the speed of the animation. And that means that basically we don't want any lag in the paddle appearing. We want it to show up, as soon as we sort of load everything. And so that's kind of something that we do for paddle B as well. And you'll see that a lot of the same things we're defining for paddle A are repeated for paddle B. Next, we have the shape of paddle A. So as you saw in that, in the presentation slide, we kind of had it defined to this square shape. So we're going to set the shape to square. And then next we have the color. Here we're defining to have a white color. You can choose any other color you want, but just because we have the window color as black, we want the color of the paddle to be white, and we kind of keep that the color of white kind of consistent for both the paddles and the one ball. And then here we're actually changing the shape size just a little bit, because it's not exactly a square, because it's a little bit more of a rectangular shape. So what we're doing here is actually we're stretching out the width and we're making the length a little bit shorter. So that's why we kind of have to stretch out. You can sort of follow along with these comments here. Those are there to sort of explain the code a little bit better to you. So the square shape is not quite right, not exactly what we want. So therefore we're stretching out the shape's width and the length. And then we have this .pen up. And so we're doing this because we don't want a line to be drawn while it's moving. So in Turtle, you kind of have this thing called a pen, and we're going to be using that pen a little bit later on. But we define pen up because right now, if we don't define that, then anytime the paddle is moving, it's going to be sort of drawing sort of its whole path along the screen, but we don't really want that. There's no reason we would want sort of to see the previous movement of the paddle. We just want it to keep moving. So we have to define it as pen up. And we do the same thing for paddle B. And then essentially everything up to here has been the exact same for both paddle A and paddle B. As you can see, we defined it as another turtle object. We have the speed set to 0. We have the shape as a square, color as white, and we slightly changed the shape, the square shape. But what's the difference here is actually the location of the paddle. So we define that by saying .go to, and then here, this is like an X and Y coordinate essentially. So we want this to be vertically centered in the screen on the left-hand side. So if you look at 0, 0, that's like kind of like the origin point. That's the exact middle, the exact center of the screen. So we want the paddles to be sort of in the middle, but on the left side and on the right side. So for it to be on the left side, we kind of have to go to a negative value, and we define it to be negative 350. And then for paddle B, we basically have the Y coordinate also as 0, but now the X coordinate becomes positive 350. So they're essentially the same distance from that origin point, but just on opposite sides. So that's how we're able to define these paddles in directly opposite locations. And from there, we're now going to predefine moving directions for these two different paddles. So to that, we have 4 paddle functions here. So first we have paddle A up, which is basically moving paddle A up. Then we have paddle A down, which is moving paddle A down. And the same thing for paddle B, we have the up and down functions. And as you can see, we kind of have a lot of this code is repeated between these 4 functions. So I'm just gonna quickly say what are the differences. So first, we to define this Y variable, which is essentially the Y coordinate of paddle A. And here we're setting that equal to the .y core of paddle A. So all of these different things like pen up and color and shape size, these are essentially different methods that we're using that come with Turtle. So that's why we're using Turtle, because it has all of these things available to us, because it's kind of the simple graphics library that we have access to. So we want to first retrieve the Y coordinate of paddle A. So like what is the current Y coordinate of paddle A? And then if you want to move it up, then we're going to essentially add 20 pixels to the coordinate value and then set that equal to Y. So this right here where it's plus equals, that is essentially equivalent to Y equals Y plus 20. So you're essentially taking the original value of Y, adding 20 to it, and then setting that equal to Y. So you're basically replacing the original value of Y. But this is a nice shorthand way of doing that. And then you basically set that Y to the original Y that you had here. So you kind of repeat the same process for the next 3 functions. So for paddle A down, here you want to subtract 20 pixels because you're going up versus you're going down, but it's still that same value of 20 pixels. And then we're doing the same exact functions for paddle B. So here we are retrieving the current Y coordinate of paddle B, adding 20 pixels, and then setting that equal to Y. And then the same thing for moving it down. We get the Y coordinate and then subtract 20 pixels. And then from there, what we'll be doing is defining our ball. So the actual ball that's bouncing between these paddles. So first we're going to actually create the ball. So we have this function called ball_create. And inside here, similarly, like we did for the paddles, we have turtle.turtle. So essentially defining a new turtle object, which is called ball. We're setting the speed to 0, basically that maximum speed for the animation. We want it to be of a square shape. We want it to also be of a white color. And we want to do .pen up because we basically don't want the pen to be drawing wherever the ball is going. And here we're setting the initial location of the ball as 0, 0. And that makes sense because you want it to start out right in the exact center of the screen. So that's like your origin point. And then we have .dx and .dy. So dx and dy are typically, in math, are sort of representing the speed in the x direction and the speed in the y direction, or some sort of movement in these 2 different directions. So we're defining the dx to be 0.5 and the dy and the dy to be also 0.5. So essentially we want the x and y movements of the ball to be equivalent at 0.5, and then return ball. And so right now what we're doing is just we're defining all of these functions. We're not using the functions yet. We're not calling them in any way. That's what we're going to be doing in the next step, which Karen will help to walk you through. Right now, I'm just sort of showing you all of these functions that we're predefining, and then we're going to actually be calling them, and you'll actually get to see them working in action. And then our last function here is the score. So to write out the score on our window, we're going to be using a pen. And so we have our pen and scores function here. And we have a score A and score B. So basically these, we're declaring these two variables to represent the score for player A and the score for player B. And these initial values are set to 0, which makes sense. You know, you start out the game with the score of 0 for both players. And then next, we're going to be using a pen to actually write out the scores. So again, we're declaring a new turtle object to be our pen. And then a lot of this code is repeated. We have the set of we set the speed of the animation to be 0. We have a square shape. We have a white color for the pen. And then we don't want a line that's being drawn while the pen is moving. So that's another thing to make sure to define. And then next, we actually want to do .hide turtle. And that's because we don't actually want to see the pen on the window directly. And some of this will make a little bit more sense when we actually start to run things and you can see kind of what this looks like. And then next, we want to actually set the location of where the score will be displayed. So again, the x coordinate is 0 because we kind of wanted to start out in this sort of where the origin is, but we want to do positive 260, which is basically going to be, you know, a little bit higher up on the screen in the y direction, sorry. And so 260 is kind of just the location that we thought would display the score the best. You can, you know, feel free to change it to 250 or 270 if, you know, if that works better for you, but this is kind of the code that we have come up with that displays the score the best. And now we're actually having the pen write. So we're using the write method to actually write out, you know, player A, player B, and then we're aligning it to center because we want the score to be centered in the middle of the screen. And then we also have the font. So we're basically setting the font to be Courier, the text, the font size to be 24, and then normal. Again, you can change these, feel free to, if you like another font better, if you want the font size to be bigger, if you want it to be bold or italics. But right now we've kind of just kept it simple to this. So these are all the functions. These are some that are actually going to be defined in the next file that Karen will be walking through. So we don't really need to define those here. But these are all of your functions that we have. And so hopefully everyone kind of has a sense of how all of these are working together. Before handing it over to Karen, maybe I can check if there's any questions. Karen or Stephanie, are there any outstanding questions, or do you think we can jump to the next step?
We can, let's see. Haley, your question I'll be taking on. Ellie's solution is yes, that's actually the way to do it, but I'll show you how can you actually do it. Then we'll demonstrate it later on. And Rishika, would you wanna talk about turtle? Because I think one of us, sorry, I think let me guess. Misty was asking like she's curious about the turtle class, and from my point of view, it's like the turtle library is like a Paint version of Microsoft, so you can draw stuff on it and you can plot stuff.
Mm-hmm.
Is there anything you want to add on to it?
Yeah, so yeah, that's a really good way to describe it. You can use, as you saw, you can do a ton of things with Turtle, and it kind of has these sort of coordinates in the background. You don't visibly see these coordinates, but that makes it really nice and easy to define things exactly where you want them on the screen. So when you're designing simple games, when you're designing, you can even you know, use Turtle to do like a simple drawing for you by just defining where the different points have to go. And then you have this pen object that you can define through Turtle, and you can have it draw through different things. So there's really a lot you can do with Turtle. You don't really have to install anything on top of Python. You just have to import it, and then you can use everything. So I think it's a really handy thing to use, especially if you're a beginner to Python. I definitely had a lot of fun using it when I was taking my intro to Python class. Yeah, so hopefully that clarifies the question about Turtle. Is there anything else, or are we good to?
Yes, I'll when like I'll just answer your question, like I'll just answer it live. So it's faster than typing. So if basically if you're on the Pong new file, am I naming this correctly? If you think Pong new file, yes, it would make sense. Because the reason because like we are actually use the point new.py as a function one. Remember we talked about the module. If you guys were in that session, we're actually using the new.py file as a module. And then we're going to use the main file, main.py to plug everything in, to hold everything together. So that's why it's normal. And but then when you pull everything in, and on the main.py, it shouldn't be an error. But let me know if it does, and I'll go fix it. Any other
Right.
question?
Let's see, I don't see any more in the Q&A. I think we're good to go.
Yeah.
So I'll stop sharing. And Karen, if you want to.
Okay, I will share my screen. Ooh, okay, so I'll actually start from the beginning. So you see my beautiful background. So like from where we left off, we start off in terminal, right? Like on the Windows, for the Windows people here. So you open the terminal, and then I want you guys to get. So Rishika show you guys how to open the point new. To open up. Open the Python file on from Mac side. I'm gonna show you a quick way to do it on the Windows terminal side. So especially when you have Visual Studio Code. So the one is, so right now you are on this directory, just like you know. So you have to get through your like the directory that you save your file in. For example, I usually save things in my desktop. So you have to do is like cd.desktop and get to the desktop file. And you can, as you can see, I have all the files on the desktop. So if you want to check your files in the desktop, you type directory dir. For Mac, you type ls, list, like list stuff. So so you can see it here. You have like the main part, the main.py, and you might not have the main solution yet, but I'll provide you guys later. And then you have the main news. Just make sure these two files are here. The cool way to do it in Microsoft Code is you can just type code, CODE, and then space and dot, and voila. Sorry, on the other side. Let me switch it back. And you have your Microsoft Visual Studio Code ready. So if you have nothing, if you this is a blank screen, because they saved my last setting. So so I have things ready. But if you don't, click this Explore or Ctrl+Shift+E, click it, and you should be able to find your files here, and then you can open it from there. You can open your files from there. So I would strongly recommend you have the same setting as me, new.py and on the left side, and then main.py on the right side. So to do that, for example, if you open it, to do that, you just have to drag the main.py on the right side. Oops, it's being funny on me. Hold on. And then you will get the you will get it, the split screen. So so make sure everyone's good. Okay, awesome. See a B. For those of you who use another editor, or like Anaconda, you open it with your if you're using Anaconda, I know some of you download Anaconda on the second section. Just you can use Spider. Spider is a good way. You can do the exact same thing. Go to your file directory, and then type Spider. Type the Spider and then dot, and then it should be like you should do the exact same function. It should get you to the exact same thing as I am. So for those of you who are not, we can do it the way Rishika was showing. So you can just click the file, open it, and then open with. And then you should have your just choose the editor you just download, or like the simplest way you can just check it in the notepad. But that's we if you don't have anything, notepad is actually fine. But like having the Visual Studio Code editors, it will be a lot easier, a lot clearer. So I'm gonna stop here. Just making sure everyone has everything ready. I'm gonna wait for some bees. Yes, I see some bees. Yes. Okay. Oh, cool. Let's go. Okay, so Rishika did a really good, really good job explaining how the things happening on what's happening on the Ponu PYS module. So I'm gonna do the main function. I'm gonna do the main, pull everything together. So I'm gonna do. So I'm gonna explain what do you guys have in the file first. So like on the settings. So the way to import the way to import the Python file as a module is like to do new dot like from new dot import import the star, that is like importing everything from there. So that's exactly why I write it as a function on the new so that I can plug it on. So we will be importing the exact same libraries as the other script, as the module. And this is just because later on we will have a sound. We should have a sound. If the ball hits the paddle, it should make a sound. For Windows, it's a little tricky. It's a little different than Mac. So if you're a Windows user, you will get this wind sound. But if you're Mac, like you won't. But there's nothing you guys worry about. Like we're not gonna set anything. Everything is set here. So I did a little walkthrough here to do what we're gonna do on this file. So first of all, we're gonna create a screen. We're gonna create a board for everyone to for everything to place on. And then we're gonna create two paddles, like a rectangular shape, like you guys saw on the intro slide. And then we're gonna create one ball, and then we're gonna set up the scores and pen, and then we will play the game by setting up two rules for the balls to bounce around and how to score it. So one is border checking, so border, like check the border, and one is what if the ball hits the paddle. Okay, so let's dive in. We will create a blank screen. This you don't have to type it. I already set it everything. So we use a function on Turtle on the Turtle library, and then call like screen, and then we create a blank screen, and then we call it title Pong, and then we change the color to black, and then set up as width as like 800, and then height is 600. And then we trace it, and then we just don't we don't want it to upload, so we want it to get real time updating, so trace it set this as a 0. So after we have the screen, we're gonna create the paddle. So if you see here, you remember here on the left side, you have create paddle B, paddle A, and and then you just have, if you want to create, because if you see this function, it returns these two functions actually return the paddle A and paddle B for you. So all you have to do is to call the function without typing anything and to set up the paddle A and paddle B. Now, Haley asked a very great question, in case everyone didn't see it. So what if I want to create multiple paddles? So the way to do it in the multiple paddle, I would do actually, so for example, I will show you the difference. For example, the difference between the two sets of code is the direction. It's the default location where it is. So what you can do is actually copy the script and place it. You guys you guys don't have to follow, but like we can just, like, if you guys want to learn, like feel free to follow me. And then you can see paddle create, and then what we have to do is set up, like I said, that the only difference between the two is the direction. Let's say if we want to, the shape and everything is going to be the same, but like I want to place it somewhere else. So all you have to do is to like location, just to give a variable, and then change this as a variable location. So it will return paddle. Sorry, so it will return. So we're gonna call it paddle instead of paddle B, so we don't have to shape it like this. So making sure your all variables are consistent. So paddle, 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 and then return as a paddle. So that way you will be able to create like a exact same paddle with different location. So how do you do it is you can do paddle C, and then you can type paddle create, and then put it as a location, let's say 200. Like you want to set it as a 200. So this is how you create multiple paddles with exact same setting, only one or two variable changes. If you want to do it, if you want to, change it to like different color, you can even put it as, you can create a variable color and then change it to color. So that's how you do it. And you can do, you can change, you can change it to whatever way you want. Just remember to add the location and color, and then do the code. Remember to plug in the location and the color, like this exact same parameters from there. So that's how you do it. So for demonstration's sake, I'm not gonna I'm gonna like comment out this first, but yeah, just like this is how you do it. So after we create the pad, after we create two paddles, we are going to set something. So we want to set some listener. So listener in a way in a programming is like calling, like waiting for like a command, like an order. So sorry, oh, Missy is asking why I want to add location and color, because okay. Sorry, we're going back a little bit. So here, if you see, so the difference between A and B, paddle A and paddle B create, these two functions, the difference between it is here. So go to like paddle B dot go to. So this is a location, like location where exactly it is. So if we want to create a multiple paddle with the exact same shape, with exact same thing, exact same color. So that's why we have to, so instead of like typing the exact amount here, the exact integer, exact number here, we can do it, like change it to something like, location or position, if that makes sense. So position here, like you can, so for example, if you do it, like if you plug in a position here, and it will, if you put it in position here, it will just create a paddle there where you want to be. You will create multiple paddle in multiple position. like without typing, without repeating the code, or like we again and again. So that's why the position is there. If you want to create the path, if you want to create multiple paddle, but with like different locations. So here is just like, you know, a calling that like I want to do multiple things, but I like there are many things that is this exact same. I don't want to repeat it. I just want to change it. So that's how you do it. I hope it helps. It doesn't. Let me know at the end. We will let you. I'll walk through it with you again. And then so yeah, we want to do some. We want to control how. We want to control some like the paddle up and down. So the way to do it will be set. We wanna like associate with the keyboard, our keyboard. So basically, if like a winner was saying like, why is it not working? Because these functions are meant for here. So if you see it like as Rishika was explaining, like this is the direction we want to control. So if you basically we will call it here. So basically we want to do like when pedal up. So when we type W, it means pedal up. When we type S, it means down. For pedal A, and then like pedal B is like up. Like, you know, pedal B is like up, and then pedal B down is the down key. So this is how you do it and how you control the paddle and play the game. So that's about the paddle. And afterwards, we're gonna create the ball. See, functions is so convenient. You can just do anything. You can just like, you know, create multiple things with like one line of code. So this is how Python is built. Actually, this is how Python library was built. Actually, so here and like Rishika was explaining, this is how we set up what we want from the ball. What we want, like we want the white shape, we want to be pan up, we want to go to the location with this exact location. The go-to ball dot go-to is to tell where we want the ball to start. So we have everything ready. So all you have to do again is to plug in the function. So ball equals to ball underscore create, and then the bracket, because it's the function. And then after we create the ball and then we set up the score, same thing, we will set up because we want the score, right? We want to make sure we keep another score, and then pen. We want to write down we want to show where the score, like how the result and everything. So we will do pen and scores. And then all we have to do is to plug in the functions. And then because we tend to we return three things, and we want to call out three things. So that should be straightforward, fairly straightforward on how to plug in, how to create everything. Up to this part, is everything okay? Is everyone okay? Awesome. Okay, let's do the fun part. Okay, it's gonna be a little chaotic, but I'm gonna go as slow as possible. So just follow up with me, just have some fun and type something with me. So now we have everything set up. Like I said, we have two rules to play the game: border checking and then collision. With the ball when the ball hits the paddle. So we're gonna do something. If you get confused, like why this function is where is you know, don't I would say not to worry about it. Just maybe copy it and then get a hang of it, and then when you go back and you will understand like how it is. Like it will help. So we're gonna set a while loop because we're gonna to repeat it like indefinitely until you make certain condition. In this case, we don't meet any condition. The way you stop the game is to close the window. Just so here, and then we wanna put this. You guys have it already. window update. So basically, like we want to update the screen, we want to update the score, like where the location is, so nothing is reset. So basically, if the ball is here, then like, you know, it just keep going, right? And so, and then we want to set up like move the ball, right? We want to make sure the ball is moving, and we want to make sure the ball is moving. So so that's how we set it up, and then we just like tell them, like, you know, keep moving, just keep changing the direction. Okay. Hopefully you guys have more stuff than me. I don't know why I have nothing. So rule number 1 is the border checking. And then so basically we want to set a boundary limit first. Screen. And then so how do you set up is I'm gonna do it in a way that like I don't have to type out anything. So so I use win.screen size. How do I know these functions? I Google it. So like I wanna get, so basically win.screen size will, as an output, it would be width and height. So y is the height, x is the width. So I'm gonna basically I'm gonna call the height. So I use the 1. And then so this is how you do it. Okay, let's do this. So x limit is win.screen size, the end of screen size. And then like this is the width, this is height. So with everything starts from 0, so that's why we start from 0. And then so basically I limit, so boundary, right? Just picture a boundary, right? So here. And then we want to make sure it doesn't go, we want to split it in half. So here, so just split it in half, like, you know. And then we want to make sure it's -10. So is like we want a -10 just to give a buffer to do so. And then so this is the limit we're setting. And then so because like it will return as a float, like as data types. We want the exact same. We just don't want any like decimal. So we're gonna call it as an integer. So we're gonna make sure this is an integer. So that's how you do it. Is everything okay? How to create step 4. Okay, so I'm gonna do this. So I'm gonna do it very quick for you guys to catch up on this. I'm gonna do some score. Oh, maybe I can. Okay, so I'm gonna do it real quick for you, Misty. So here, so you can see pen and score. So basically, I have the function and set up like score A and score B equal to 0, and I have like some settings of the pen. So basically, I wanna like these like, so you know these are the variables in the functions. So I want these. I just treat it like a machine, right? Like a FX machine. Like if I plug in something, I want to come out something. So I want the person who use this function, like if they use this function, they will get 3 things from me return. So I wanted it to score A and score B and pen. So I like, because these are the setups, like I don't have to type here. So like I set up everything. I want like, you know, just give them like, you know, they use this function, just give them these 3 things. So on here, I call a function. I call this function pen and scores. And because it's giving me 3 things, because I know you know, if they're expecting me to have 3 things, so I'm receiving 3 things and calling me 3 things. So I call it score A, score B, and pen. So you can do that. So basically, you basically do, you know how like this is like calling it, like declaring a variable, and like as a ball and then call it. Same thing here, but it's just like, do it at the same time. Like you're calling out 3 things at the same time. So this is how it is. I hope it helps. And we will go through it after, if you're not sure, like you show, okay, so like now we set up the boundary. Okay, let's back to border checking. And then, so we're gonna do some top and bottom first. You guys should have more stuff than me. So, okay, so we wanna, so basically, here's the thing. We want to, when we want to do something, when we exceed the limits, when we reach the limit. So this is the Y limit, like this is a high limit, and this is the width limit, right? So we will do something when it exceeds. So we call out the Y coordinates here, and then so basically is when the ball is bigger than the limit is supposed to be, basically at the boundary of what even trying to go beyond boundary. But the two things. So one is to set Y at the Y limit. So do not go out. Like no pass. You shall not pass. And then we're gonna tell him to step back. Like, back up a little bit. So basically we want to make sure Hoshino, we want to -1, so that you step back a bit, you step back 1 position from there. So this is how you do it. Fairly easy and simple it should be. And then here we like I said, we were having a platform. We wanted to make a sound. You guys download the sound, the bounce.wav. So when it happens, we want to make a sound. This is something a little fancy. You don't need to, but like it'll be, you just treat it as a challenge. I wanted to have a bounce sound. So this is how you do it if you're Mac. And so if you're Mac, this is how you do it. Just doing it so that so we can do it in both Windows and Mac. But if you a Windows user, just type the first line of code. Just type this and you are good to go. And if you're Windows user, type just follow me and type this and you're good to. You don't really need the if statement. When sound dot SFD. How do I know? I Google it. Let you guys know, in case you guys are wondering, how do I know what function to use? I don't. Okay, so and then same thing. So now we have the Y limit. The Y limit is on the positive side. So think about this, like this is X and Y. So sorry, mathematical, little bit. X and Y is the center of the thing. So the first half, the top half is the positive. Lower half is the negative. Same thing on the width. Right is the positive. Left is the negative. So we're gonna do the exact same thing. Basically, let me copy this. So LF, remember to change your LF if you guys want to copy me, like I do. So instead of like doing the Y limit on positive side, we're gonna do it like negative side. So we put a minus there. So and here, same thing here. If the ball reaches the limit of the lower half, then you go back to try to go beyond the lower half, set the ball back to the limit where the limit is, and then do the exact same thing. Step back. Reverse the direction basically. So this step back is basically reversing the direction. Tell them change direction. And then do the exact have the exact same thing. Bounce it back. Just bounce it. Just make the bounce sound. Exact same thing. So we're doing exact, so this is how we treat the bottom and we treat the bottom and, sorry, top and the bottom. Now we're gonna go through left and right. So if you guys have a good idea what is going on here, the code should be fairly easy for you guys because it should be the exact same, except it's like X limits. So set X as X limit table 0, 1. So basically -1 exact. Be careful. So everything with basically here, everything with Y, you set everything with X. You want to copy it, feel free. Just be really careful on what are you copying. Just remember to change all the Y to X. So that if you don't have that, it's gonna, be cranky. So just making sure, or you can be like me, typing. So if ball.x score, when it reached to the lower half, I mean the left side, then you do set X. So negative X limit. So the code here is the exact same, except like this is the, the first tab is like Y for Y, positive Y, negative Y, positive X, negative X limit. So, and then you do this, and then you set the ball, change the direction of the ball by here. And then type this, and then repeat this. Yeah. Okay. So that's for the border checking. Let me see if anyone has anything. Let me see. You're right. Thanks, Alice. You're right. Sorry. So yes, math problem. So so this is like beyond limits, right? So this is like reaching the limits. So like for the positive part, it should be like, when it before limits, and then like you do it. And like for the lower part, it should be anything smaller than anything you want trying to go to smaller and smaller, then we will stop it. So when it's negative, it should be less than the Y limit, less than the limit. And then you always a big help with these. Thank you. So here, so you have to change it here. So just be cautious of the sign, a greater than. So for anything positive is greater than. So the arrow goes this way, goes to the right, and any negative, the arrow goes that way. So if that helps, in case you're as confused as me on the arrow, way to go. That's how it works. So is everybody okay with that? Is everything lost? Is everyone okay? Thank you. Thank you. Thank you. Okay, so I'm gonna go. So basically, we're gonna do like the ball boundary. Just gonna do two things. Basically two missions. Set the boundary if we try to reach the limit, and like beyond the limit, and then just reverse the direction, and then play some sound if possible. So this is what we're gonna do. So basically, this whole line of code is really just three things to do. Okay, so now we have the boundary set up, and then we're gonna do the collision. So the collision, when the ball in collision, like how are we gonna do it? So basically, we're gonna set some buffer. So basically, it's similar to the limit, and on like how it touched the paddle. So we call it X paddle buffer X limit is 10. So -10 is like, give it like this is the limit, but we want to like get a little bit like buffering. So like, you know, even more. And then Y paddle, we're gonna go in a little bit. So Y paddle buffer equals to 50. So that is like the buffer we set, the ball, how should, like, you know, when we want to decide where the ball hit the paddle. So we're gonna do, basically we're gonna do exact same thing actually. Let's do this. Give me 1 second. Check it out. Okay. Okay, so we're gonna basically we would do the exact same thing. How do we do it? So we want to make sure we're gonna fill out a whole bunch of conditions, and then to tell them, you know, when you hit it, you reverse. Like that's how you do it. You hit it, you reverse. So now we're basically doing the very similar thing here. So X coordinates, you can just copy from me. X coordinate, X paddle buffer on the side. Y coordinates, and then paddle A. Y coordinates plus Y paddle. So this is how, and then we just pulling a whole bunch of conditions here. You can just copy me, because I'm just copying too. Okay, so this is the condition. We have 3 conditions here. So when the coordinate is, you know, is less than the paddle buffer, and the Y coordinate is the paddle A coordinate is less than Y coordinate, and the ball coordinate, so the board, like where the ball is less than where paddle A is, plus the buffer, plus the Y paddle buffer, plus the height buffer, and that's the same thing. So X, and the Y and the, wait, hold on, oh yes, so and the Y coordinate is greater than like the paddle A coordinate minus the buffer. So that's how it's set up. So if it does, then what you do is you bounce back. -1. You reverse the rush, step back. And then you will type, and then you will make the sound. You can skip the sound for now if that's at the complexity. Okay, so this is how you do it. So we're gonna do the exact same thing there. So we're gonna do LF ball X coordinates greater than X paddle buffer, and Y ball Y coordinates is above. So basically for paddle B. So that is for paddle A, and this is for paddle B. So Y paddle buffer. Title, guys. Paddle B coordinates minus Y paddle buffer. Exact same, but it's for B. It's for paddle B. So this is for paddle A. And this is for paddle B. Okay. So they're gonna do the exact same thing. So I'm gonna copy everything. the exact same. So just copy. So you don't have to change anything here. So that's how you do it. Is everybody okay with that? I will give you guys one moment to copy it. Miss C, do you want to let me know anything that you're working on that you don't like you confused with? Oh, let us know if like if it's like the first couple section like I'm sorry if like I'm too fast or too confusing. Do let us know in the Slack, join us on the, if you're not in the Slack, join us on the Slack and let us know what to do. Let us know like what you're confusing on. So we can definitely help you with work with this. Sorry guys, when you guys trying to understand it, I tricked you guys. I'm so sorry. That the X coordinate, the list X limit is not we support we supposed to do. I'm so sorry. So you guys will see the code. You guys will see the code later. Okay, I'm just gonna do a quick explanation. Do not have to change anything. Just sit here. If you're sitting here, good. If you're not, you're typing. Don't worry about it. I'm gonna do a very quick demo on this. My bad. So basically here we go back to the boundary. So the boundary, we're gonna do boundary checking. So basically the paddles are the boundary. So basically how we know it scores is the boundary. So what we're gonna do is to change it here. We want to score and pen down the stuff instead of like just set the limits. We were gonna use something, but then I'm gonna just stop this. So basically we're gonna score and pen it down. So pen right. We have so basically we want to clear something first, and then pen right. The what is player A has. And player B. And then, so remember we talked about the formats on the Python module. This is where we use it. So score A and score B. I'm going to go through it very quick. And so besides that, we're going to have some, so that's how so this is basically a print statement. It's the exact same as print statement until now. And because we want it to be pretty, we're going to do some like a front end setting. So basically we're going to do, if you're familiar with front end, do HTML, CSS, this is what exactly we're doing here. So just letting you guys know, here, and then 24, and then normal. So basically, when you score, we want to reset the ball, just like soccer game. Like when you go, the ball, the game starts back in the middle. So you change back the direction. One here. So this is how you do it. And then here, so when the which is the right side, this is what you do. When you wish the left side is basically the paddle E of the score B. Sorry. So basically when on the right side is the score is this paddle A wins, which is the paddle B wins. So this is how you do it. I'm so sorry again to confuse you guys. So once you have the code ready, ooh, let's try it. So this is a complete code. Oh, sorry. So after you done it, we will run it on the terminal. So you play. Like I said, like you make sure you're on the same file, or you're on the same directory as your file. All three of them, like Panliu, main, and the mouse sound. So all you have to do is to type Python 3. Let me clear this. So Python 3, and then type main.py. It should show up. Sorry, give me 1 second. I'm going to fix it. Okay, so what I did wrong here, because I have the sound, because I do a little typo here. So play sound supposed to be play sound. Replace. Okay, so this is how you do it. See, so if I want to play, I just have to do up and down. So this is how the game's supposed to work. So, okay, so that is the demonstration for today. I know it's a lot. If you guys have any questions, I think you guys like stop typing probably. But you guys have any questions, please let us know again. So I will let Rishika to wrap up, and then we will answer some final QA.
All right, thanks, Karen. That was a lot of fun. I hope everyone was able to get all that code up and running and could kind of see that final end product. So with that, this is now as we mentioned, the last session for the Beginner Python Study Group series. And so this is just a quick wrap up, going over what we all went through, what all of us everything that all of you learned through all of these 8 sessions. I hope you all enjoyed each and every session, and even if you couldn't attend all of them, we have all of the recordings up on YouTube. So just to go over something that we went through, we sort of talked about, why do we use Python? Why is it so popular? Its advantages and its various applications. We also talked about the use of Google Colab, so we used that through the first 7 sessions. Today was a little bit different, but that's definitely a really important tool, and I hope all of you can continue to make use of that on your own time. We talked about libraries, whether it's installing, importing, and how do we use them, especially with the pip install command. And we talked about the different data types, so we had that kind of split up into 2 different sessions. Then we talked about flow control and programming logic, so we introduced if and else and elif. And then 2 different kinds of loops with for loops and while loops. And you saw some of those being used today in our live coding portion. And then we also went over modules, functions, and how those are kind of go hand in hand when we're talking about object-oriented programming, which is a kind of an advanced concept when it comes to programming. And then today, obviously, we went over our mini project, which was building out the Pong game using Turtle. And I hope everyone was able to enjoy all of these 8 sessions. I myself had a lot of fun. I had a wonderful team alongside me through all of these sessions, and we really worked really hard to sort of make this the best possible series for all of you. So I hope all of you had as much fun as all 3 of us did. And so if you have any further questions, we have been sort of dropping in the Slack channel in the chat throughout today's sessions, but there it is again, the Slack channel dedicated for this study group. And feel free to join our Slack community. We have other series that are constantly popping up and other sessions. So, you know, hopefully you all can join the community and we can all interact and stay connected. And I think Women Who Code has this amazing ability to create connections with people that even are on opposite sides of the world. I've worked with Karen and Stephanie for all these months, and I haven't met them in person, but we're already trying to make plans to maybe meet up next year if we can. And yeah, with that, thank you everyone. Thank you, Stephanie and Karen. You both are amazing. Yeah, I think that's all we have for today's session. Thank you everyone for joining.